Hello everyone, it's time to move on to Chapter 9. Only 3 more chapters until the end of school. Yay! Okay, this chapter is going to be a wee bit of a review with some twists, okay? So it gets a little more complicated, but let's start with what you already know. The first thing we need to do, though, is make sure that you have your comp book with you, that you write your title down and your I will statement. Don't forget to write your title in your talk as well, your table of contents, which we are going to start the formulas for triangles and quads. Okay, some of the new quads and adding to it. So the first thing I need you to do is to get all of this copied. You don't have to worry about the titles or anything, but please get the names and the diagrams and the formulas written down, and then you can come back and join me and we will go from there. All right, so go ahead and pause me and I'll see you in a sec. All right, are we back? Okay, the first thing we need to do now is to take the 2 pieces of paper that you picked up in class. Okay, you probably got a blue one and a white one maybe. We're looking for the one that has the little house on it like this. Okay, I need you to fold it so that the white side, the clean side, is inside. All right, so just fold it right through there, and then you can fold it down. See how this is one right here? I'm going to fold it back and down so it makes a flip book that goes upward. All right, so you have this on the front. Okay. All right, so let's see. The first 2 questions, these are nice and straightforward. I know you can do these, so I'm actually going to leave these to you. I do want you to finish them before you come to school tomorrow, all right? So the area of the trapezoid, area of the triangle, all right? So you've got your formulas right up here. Just plug in what you've been given and solve for the missing, okay? All right, so but when we open it up, I do have one of these that I want you to do once again, a nice simple one that I know that you can do all on your own, and you can come back tomorrow and show us how much you know. And then on this one, I want to show you. This is just we're finding the second base of the trapezoid, in which the area is 5 feet squared, height is 2 feet, and the base, one of the bases is 1 foot. All right. I didn't draw it, even though that's a really good idea. I just have my formula here for the area of a trapezoid, and then I plugged in what I have. Okay, they gave me that the area is equal to 5. The 1/2 comes from my formula. I have one of the bases is equal to 1, and then the height is 2. Okay, so then I just put these together, put the 2 there, and then the 1/2 went down here. These kind of cross out, so it makes your algebra nice and easy, and the second base is equal to 4. Okay, you probably want to pause me so that you can get all that written down and then move on to the next one. Okay? All right, got all that one down? Let's move on to number 5. Okay, on this one it says Samantha's buying stones for a 16-foot by 3-foot walkway. She needs to buy 10% extra for cutting stones for the corners and ends. The stones are rectangles, 7 inches long and 4 inches wide, and cost 97 cents each. About how much will the stones cost for her walkway? Well, you know, when we work with 2 different units, we need to really and truly get everything in the same thing. So instead of putting these into just decimal portions of feet, I went ahead and changed the feet into inches. So we ended up with 192 inches by 36 inches. I found the area for both of them. The area for just one single brick is 28 inches squared. And the area that she's going to need to fill for her entire sidewalk is 6,912 inches squared. Okay, well, I then decided to take this area and divide it by 28 to see how many bricks I was going to need. And that gave me this. And you know, when you go to the hardware store or lumber store, or lumberyard, you don't ever buy a portion of a brick. So we need to round it up. She may have to cut it in order to fit. So now we have 247, but what else did it say? It said that she was going to need 10% more for the cutting stones in the corners and ends. So I multiplied it by 10% and found that she needed 24.7 or 25 extra stones in order to complete her sidewalk. So I added them together, the 247 and the 247.1. I got 271.7 stones. I rounded that up to 272. I multiplied by 97 cents, and I got my final price. All right, these are the kind of questions that you're going to see quite a few of, so make sure that you kind of go back through this example and really understand how we found the final price. All right, let's see if there are any more. Yes, there is one more I want to go over with you, so you can turn your paper over after you have finished copying the other ones down and work through this one with me. This one says that you have a house The house is made from 7 puzzle pieces. The pieces are triangles and parallelograms. If the area of the chimney is 1/8 inch squared, what is the area of the triangle LMN? So that's this triangle right here. Well, the first thing we need to realize, they told us that the area was 1/8 of an inch. Well, they didn't tell us what the sides were. So it's a little bit of a guess and check, but you need to find out what could the sides have been in order to come up with an area of 1/8 inch. Well, it looks to me like 1/2 inch by 1/4 inch would give us that. And the chimney is 2 boxes long, okay, on either side, and it's 1 box wide, all right? So each box ends up being 1/4 of an inch square, because 2 of the 1/4 inches would make the half, okay? So the half right here times 1/4 inch gives us the 1/8 of an inch for area. All right, now the triangle, this LMN triangle, the formula for the area is 1/2 base times height. We know that every box or every square is 1/4 inch, so I multiplied 5 times the 1/4 inch, so I'd know how long this was, 5 1/4 inches, times 3/4 inches, which is up this way. So working with our fractions again, it comes back down to 1/2 times 15 over 16, which gives you 15 over 32 for your area, and that should be inches, I believe, inches squared. Sorry, should have smushed that in there. So 15 30-seconds of an inch squared is your area for that one. All right, so at this point, obviously pause me if you need a little extra time to write that one down before we move into our rhombuses and kites. And you're welcome now to go ahead and tape this in, glue it in, whichever, to your notebook right under the formulas for your triangles, traps, and parallelograms. Make sure you finish the examples for tomorrow. Now, moving on to my other side, I have my areas for rhombuses and kites, okay? The one for rhombuses is just diag times diag divided by 2, and it's the exact same thing for kites. So here they actually have something in common other than their perpendicular diags. All right, so now I need you to take the other sheet that you picked up. It may have been blue. You'll see that number 1 talks about a rhombus. You're going to do the same thing with this sheet. I folded mine up and down. I folded it back so that the 1 was on this side, and if I flip it over, you know, it's upside down, there's 3, so that I can fold it like a book now. See if I can get it where you can see what I'm doing. Okay, folding it like a book. So I've got 1 and 2 on the front, 6 and 7 on the back. Okay? All right, let's look at a few of these. The first thing that you need to do is add this diagonal in the middle. He didn't get added somehow, and that's a very important piece of information. So just add that diag that's 15 meters. And then you can use your formula to figure out the other diag. Okay, so they give you the area, one of the diagonals, and you're finding the other one. And you can do the same thing with this one. Just use your formula, okay? And they gave you the area. You're looking for diag 1, and they gave you diag 2. So just plug that in and come to class tomorrow with your answer for diag 1. Now, on a few of these, I'm going to help you just set them up, and I want you to finish the math for homework, okay? This says find the area of a rhombus in which diag 1 is 4 AB inches and diag 2 is 7 AB, okay? Well, just plugging in the formula that we know, which is diag times diag divided by 2, would give you this, okay? And then, of course, you multiply them, adding your exponents the whole time and making sure you reduce it to the minimum, all right? The second one that we can look at is this one where it says, in rhombus ABCD, the length of diagonal BD is 2/3 the length of diagonal AC. If the area of the figure is 75 centimeters squared, find BD. Well, of course, it would be helpful to draw it if you want to draw it so that you can see it. But you do have your formula that you can plug in what you know. They told us the area is 75. One of our diags is 2/3 the length of the other, so we need X to represent the original, and then 2/3 of that X to represent the other diagonal. And of course, the formula tells us to divide it by 2 or multiply times 1/2. Okay, so once again, use your fabulous algebra skills to solve for X, okay? All right, so let's see. Right here, this is another one. It says Find the second diagonal of the rhombus with the area of 6x squared plus x minus 1. Now, this is a complicated little problem, but nothing that you can't handle. Go ahead and draw in your diagonals, another one of those little tidbits that was accidentally left off. One of the diagonals is equal to 2x plus 1. I say 1 because notice I messed that up. Don't mess it up on yours. Here's the formula we're going to use because it is a rhombus. And yes, we do need to memorize these formulas. Okay, same formula for rhombi and kites. All right, so we have the area equal to diag 1 times diag 2 divided by 2, or multiplied times a half. All right, so here we go. This is where I went ahead and multiplied both sides by 2, so I got my 2 here. I pulled back apart the monomials that made up this quadratic equation. Okay, so 3x minus 1 times 2x plus 1. When it's FOILed back out, you get this. And on this side, I have 2x plus 1 times d. Now, when you're working with monomials, if you have the same one on both sides, you can divide both sides by that whole monomial, and they cross out. Okay, you may be remembering some of this. So all we have left now is the 2 times 3x minus 1 equals the d that was left here. And when we distribute that 2, we get 6x minus 2 equals our diag, and that is diag 2. All right? All right, we are almost done. Let's see. Okay, I want to help you set this last one up. It says the perimeter of an isosceles trapezoid. Very important information there. Perimeter of an isosceles trapezoid is 50 feet. The bases of the trap are 12 and 20. Find the area of the trapezoid. Okay, this isn't hard. We know how to do this. You can look back actually at your other notes, which were over here, where you have the area for your trapezoid, which I know you've seen many, many times. And we'll go back over here and use it. But the first thing, I don't have a height, and I don't have an area either, so I can't have two variables. Got to find one of them. So when you're working with isosceles traps, remember both sides are equal. Well, if this is 20 and this is 12, if we know they're supposed to all equal 50, we can do 50 minus the 32 they told us, get 18 divided by 2 because they're both exactly the same on each side, and we get 9. Okay? Then I know that if I pull this straight down, this much of it is 12. That leaves 4 for each side because it's 20 all the way across. I did my Pythagorean theorem. I found my height to be square root 65. And if you're in Miss Davis's class, you know she doesn't like decimals. So we're going to leave it as square root 65 for a height as you plug into your formula. So let's see. Our area is going to equal 1/2 20 plus 12. Ooh, I got to squish. Times square root 65. Sorry, I'm squishing. Oh, I'm going to open it up so I can write it in there. Square root 65. There, I'm sure yours is prettier than mine. Okay, so square root of 65. All right, and you can multiply all this out. All right, or you can get 32. This is going to be 32 square root of 65 all over 2, which can be reduced to 16 square root 65. All right? And I can't remember if this is reducible or not. We'll talk about that in class tomorrow. All right, guys. Please try and finish them up. We can talk about number 7 in class tomorrow, but the rest of them you need to finish for your homework. Hopefully this has given you a little bit of a refresher as far as your areas for your quads and triangles. All right? We will continue to practice this tomorrow, so just make sure you bring everything with you. All right? Okay, guys, have a great day, and I will see you in class. Of course, email me or Miss Scott if you have any questions at all. Talk to you later. Have fun.